Hi everyone, so today we're going to review trig identities and solving trig equations. Okay, so we're going to go ahead and simplify each expression. So we're going to go ahead and rewrite cotangent. So I know cotangent is the same thing as 1 over tangent. And because I already have a tangent here on the top, I can easily cross those two out, and that would get me 1. So you can rewrite in terms of sine and cosine. You'd still get the same answer. So let's just go through an example just to show you that there's multiple ways to simplify the expression. So if I rewrite in terms of sine and cosine, I know that tangent is sine over cosine. And I know that cotangent is cosine over sine. And because I have sines that can cancel out and cosines that can cancel out, again, would also get me 1. Okay, and number two, what you should notice is that you do have a common factor. So that GCF, that greatest common factor, is sine of theta. So I'm going to take out that sine of theta. And what I have left is sine squared theta plus cosine squared theta. Now I know that sine squared plus cosine squared is an identity, and that is equal to 1. And so sine theta times 1 is equal to sine of theta. Okay, so let's keep going. I do have an identity here that is cosecant squared, and I still have secant squared in the denominator. Haven't done anything yet with that. You can rewrite, so if I rewrite cosecant squared, that is the same thing as 1 over sine squared. And then secant squared is the same thing as 1 over cosine squared. So remember, when you divide fractions, you keep the first fraction, you change the division to a multiplication, and you flip the second fraction. So cosine squared theta over 1. So when you simplify this, you're going to get cosine squared over sine squared. And when you simplify that, that is the same thing as cotangent squared. Okay, in number 4, let's go ahead and just rewrite in terms of sine and cosine. That'll make it probably easy for you to be able to see a couple things, see if anything cancels out. So I do have tangent, which I know is the same thing as sine over cosine. I do have my sine still here, and then that whole thing is divided by secant, which is the same thing as 1 over cosine. So when I simplify what I have here, I have sine squared over cosine divided by 1 over cosine. So you can cross out the cosines. They're both in the denominator of your fractions, which means that if you were to, again, like do the whole keep, change, flip, you would see that they would cancel. So what I have then is just sine squared of theta over 1, which again is just the same thing as sine squared theta. Okay, and number 5, we're going to go ahead and look at cosecant. So cosecant I know is the same thing as 1 over sine, and then multiplied by tangent, which again I know is sine over cosine. You're going to notice again my sines will cancel. I have 1 over cosine of x, which I know is the same thing as secant of x. Okay, in number 6, let's rewrite cotangent as cosine over sine. And then I still have the sine that's in the numerator. So again, you have a sine on the top and the sine on the bottom, right? So I hope you're kind of seeing how we can simplify these. And you've left with cosine. Okay, so in number 7, these are conjugates, which means they are exactly the same, except the signs are different. So you can multiply, again, you can multiply using your area model or your box method or do FOIL. So just to kind of help you out, let's just show you how this will work out and cancel. So you've got 1 times 1, And then you've got cosine times 1, you have negative cosine, and you have negative cosine squared. Remember that your cosines are actually going to cancel. They're opposites of each other. So you're going to be left with 1 minus cosine squared of theta. Now, if you look back to your identities, you're going to see that that is the same thing as sine squared. Okay, so we're going to go ahead and multiply. So you got sine squared of x and then plus sine of x cosecant of x. I'm doing multiplication because I can't do anything else with what I have right now. I don't have any identities to work with. What I do see is that I have sine here, but then if I rewrite cosecant, that's 1 over sine. So my sines will cancel. So this just becomes 1. And then I have sine squared still there. At this point right now, there's nothing else that you can do with this. There's no other identities. So then this would be as simplified as you can get. If it's easier for you to factor without having to see the cotangent or the trig functions, you can really imagine this being x squared plus 2x squared plus 1. So what we're doing is we're really saying that x is that trig function, which is cotangent. So you can again put this in a box and then factor. So you get x squared, and then you get 1 and 1. So that'd be 1x squared and 1x squared, which would get you 2x squared. So your factors are x squared plus 1 and x squared plus 1. Now, again, you know that x is really cotangent, so you would put the cotangent back into wherever the x was. So this is really cotangent squared x plus 1 and cotangent squared x plus 1. Now, this is an identity, so when I think about these, this is really cosecant squared and then another cosecant squared. So if I simplify, this would be cosecant, and it would be to the 4th power with x. Okay, so here you're going to notice that you have a sine and a cosine. So in order for you to factor this, you got to get them to be the same trig identity. So what you could do is you can say, well, I know that sine squared is the same thing as 1 minus cosine squared of x, which would then make my trig functions the same. So this would be minus 5 cosine x minus 7. So if I were just to rewrite this, I would have a negative cosine squared x minus 5 cosine x, and then minus 6. So now what I'm going to do is if I take out a negative 1, if it would help you to look at your factoring a little bit easier, again, you can think about that x is really the same thing as cosine of x if it would help you to factor. So you would be factoring this expression instead. So when you do that, you're going to get cosine of x and then plus 2, and then cosine of x plus 3. And we're going to bring this negative 1 back down. All right, so here we're going to go ahead and verify. Now, remember when you verify, we're only changing one side and getting it to equal the other side. So here what I can do is I have the ability to sort of split my fraction. So I can make this one fraction and make this secant squared of x over secant squared of x. And then it could be a minus and then 1 over secant squared of x. Now, when I look at this, I have this simplifying to 1 minus the reciprocal identity, which is cosine squared of x, which is sine squared of x, which equals what I wanted. All right, so here we can try to do some rewriting. So let's figure out, we got tangent. So we're going to keep sine, and we're going to make tangent sine over cosine, and still have that big fraction with secant, which is the same thing as 1 over cosine of theta. So let's see. When we make our fraction sort of simplified here, let's take care of the numerator there. I'm gonna get sine squared of theta over cosine, and then all over 1 over cosine. So again, in those both fractions, I have cosine in the denominator, and you would simplify and you would get sine squared over 1, which is equal to my identity. Okay, so here we're going to use our sum and difference formulas to figure out how to get sine of 255. Now, we can say that sine of 255 is the same thing as 210 degrees plus 45 degrees. So I'm going to take my information and I'm going to plug it into my formula. So here's my sine, and then I have my first angle, which is 210, and then cosine of 45 plus cosine of 210, and then sine of 45 degrees. Now I'm going to my unit circle to figure out what all of these are. So I got negative 1/2 times root 2 over 2 plus negative root 3 over 2 times root 2 over 2. So when I multiply, I'm going to multiply top and the top, and then the bottom and the bottom, plus top and the top, bottom and the bottom. So now when I combine, I have negative root 2 minus root 6 all over 4, which is answer choice C. Okay, so here we have a sum of sine. So the same thing, we're going to use our formula with our angles. So the sine of 3 pi over 2 times the cosine of x, and then plus cosine of 3 pi over 2, and then sine of x. So here we know that sine of 3 pi over 2 is the same thing as -1, and then cosine is 0. So once this is 0, what actually happens is that this cancels out, and I have negative 1 times cosine of x, which is the same thing as negative cosine of x, which is answer choice letter B. So here we have cosine, cosine, and then minus, and then sine and sine. So you got to look at your formulas and see which one this is. So here you have your first angle, second angle, and then that was the first angle and the second angle. So this is a cosine formula, and it's the sum of those two angles. So pi over 8 and 3 pi over 8. So when you simplify this, this becomes 4 pi over 8. And 4 pi over 8, we know, is the same thing as pi over 2. So when I think about what cosine of pi over 2 is for my unit circle, that is just 0. All right, so here we're going to go ahead and solve each equation algebraically, and you are given a specific interval between 0 and 2 pi. So here what we can do is we can get rid of the power of 2. So I'm going to take the square root of both sides. So that is just secant of x is equal to plus or minus, and the square root of 4 is the same thing as 2. I know that secant is the reciprocal of cosine, so if I write cosine, I'm actually going to flip my fraction. So I'm going to get cosine of x is equal to plus or minus 1/2. So if I go on my unit circle and figure out where is cosine, positive and negative 1/2, these are all my angles here. So x is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So these are all my angles on my unit circle that would fit my criteria. Okay, here what we're going to do is, in order for us to solve this, we're going to have to factor. So I do have a GCF, and it's the GCF of sine. And if I take out a sine, I have 2 sine of x and then minus 1. So again, still equal to 0. When I set each factor equal to 0, I'd be able to find out what my angle is. So I'm looking at simplifying this one. So 2 sine of x is equal to 1, and then sine of x is equal to 1/2. So I'm going to figure out from the information that I have. So sine of x, so on your unit circle, your angles would be 0 and pi. And then here, sine of x, that would be 1/2. Your two angles would be pi over 6 and 5 pi over 6. So here you have your two angles and your two angles. All right, so in this question, we got to get tan by itself. So we're going to divide both sides by root 3. So tan of x is equal to 1 over root 3. So the thing I want you to remember is tangent is the same thing as y over x. So what I'm really doing is I'm saying that I've got 1/2 over root 3 over 2. This means that on my unit circle, I got to look for where do I have a y value of 1/2 and where do I have an x value of root 3 over 2. So that would give me my angles, and that would be pi over 6 as well as 7 pi over 6. Okay, here in number 19, we're going to go ahead and factor. So again, if you need to imagine this being x squared minus x minus 2, because we're saying that x is the same thing as just cosine, that'll help you to factor. So this is factored as cosine of x minus 2 and cosine of x plus 1 still equal to 0. When you have your two factors, you will need to set them equal to 0 to solve. So I've got cosine of x is equal to 2, and then my second one is cosine of x plus 1 equals 0. Cosine of x is equal to -1. So now the cosine of x is equal to 2. That is not possible on your unit circle. And then the cosine of x is equal to -1. That angle would be pi. All right, so I hope you found this video helpful. Don't forget to like and subscribe for notifications on future pre-calculus videos. Thanks for watching and have a great day.